application. Let's switch over and I'll show you. The async in a way is definitely the newest way. So let's just switch over to Visual Studio. And I have a less simple example here. Okay, let me go to this one here. And this one starts from a little bit of a project that I had before. And I think I realized I was playing with it just a minute ago. And I'm pretty sure I should not have changed it, but I did. So let me just make one quick change here. Sorry about that. One more. Apologize about that. Okay, so let me just run it first, then we'll come back and talk about what it is. So this is a WPF application. And what it's going to do is it's kind of like a search engine, like a client-side Google or whatever. So what it's going to happen if I type in here, maybe I want to know about the fancy new tablet that Microsoft just released. So I could go do a search about Surface. So let me go and show you what's going to happen when we click on that. So it's using MVVM. Here's the main window view model. We're going to go down here. When we click search, what it's going to do is it's going to go to the entire internet, look at all the URLs there, and it's going to loop through each one of them, download them on demand, do a basic search, basic keyword search for the contents, and then the ones that it matches, it'll show them. All right, so the entire internet, here I can show you guys, is basically like 20 or 30 news-based websites, okay? But the thing is, this method is going to be called when I click the button, and it's not going to return until it's downloaded and processed results from all 30 websites. So let me give this a shot, and you guys will see what happens. So if I click search, you can see that the color is sort of still stuck on what it was for the highlight, and I try to move it, it's not going to move. It's totally locked up. But the program's not broken. It's actually doing the download right now. Eventually we'll see that it'll come back. Oh, there it goes. It must have not found anything. Let's go search for iPad. All right, so it's searching, thinking away. Okay, great. So finally it's gone and got the results. You know, 1 million iPads were sold last quarter. That's unbelievable. Wired.com is talking about the iPad. We can double click it. It'll like pop open a browser and show us, you know, so presumably someone here, iPad, right? So this is the article it must have found when we went and searched that, okay? So the app is working. And it turns out that it's not very computationally heavy either, because really all it's doing is waiting on 30 website requests. So this is sort of a really good example where we might go and use the new features of C#5. Okay? So they're deceptively simple. Let me show you how we do this. What we do is we can go to this method, which is just being called directly through the command binding in WPF, through the MVVM data binding, command binding type stuff. And what we can do, and we can find the part where all the slow stuff is happening, and it's line 82 right there. And we can just go to definition on that. And you can see we're using the web client. And in .NET 4.5, a lot of these classes that might take a while have been updated to have what are called task async methods. So we've had a client, we could say begin, downloads, begin, I guess not on this one. With web requests, you could say begin get response, or you could say get response async. This one you have a download string async, right? But before this, you're supposed to say client dot download string completed, and you have to subscribe to an event, and then that event is fired, and so on. So there's these previous ways in which we could do this in a parallel way, but it turns out to be very difficult to create composable software, right? So if one thing is calling another thing that's asynchronous and it's calling another thing that's asynchronous, it's really hard to make all those pieces fit together well. And it turns out C#5 is much simpler because you write what looks like top to bottom procedural code with no threading, and then you just sprinkle some magic C#5 fairy dust keywords on here, right? So the first part is to switch this from download string to download string task async. Okay, so we're going to switch this to task async, and it's going to return a task of string. Okay, and that's the task that we've seen the whole time. We can go do task stuff with it however you like. Okay, but what we're going to do is we're going to use the new keyword. We're going to say await. Now you can see it's got little squiggly lines and stuff, and it says you can't do this. This is just a convention that they put into C#5. It technically could have been done without it, but they said if you're going to use this word, you need to sort of declare your method as being an asynchronous call. So you have to say async up here, and then you can see that await turns blue, and we can now do this. Now there's something really interesting here. If I hover over this, you see tasks of string is what comes back. But on the left side, after we process and await, what we get as var is actually a string. So even though download a string task async returns a task of string, the await keyword says you don't actually care about task. That's the mechanism by which we make this work, but you don't care about task. You just want the result. You're waiting for the result and give me the result. So what you get out the other side is a result, a string in this case. Okay. Then the other thing that's weird is this is a string. Let me go ahead and write it as string now so it's really clear. We're returning a string here, but it says that you have to return a task out of your async method. So what this really needs to be is a task of string. But where it gets interesting is we say return string, and yet the return type is task of string, and there's no compiler warnings, right? If I press build, it's totally happy. Well, okay, it's not totally happy because the methods that we're using this one are broken, but you can see there's no errors in the downloader class file. It's only in the view model. Okay, so this is basically C#5. What you do is you work with methods that return task. You typically task of results. You could await a void task, but you would just have no return value. But you await the result, you get the actual result as the direct value, and then off you go. So let me run it first, and then I'll come back and dissect what's happening here for you. But there's this other problem, because back up here where we were calling this, it said this was expecting to return a string here. Right? That's how it was working before, but it no longer returns a string. So what we need to do is say, okay, fine, well, I actually wanted the value out of that. So you kind of got to walk your way up the stack and say, I want to use await here, and so in order to use await, I got to use async, just like that. And then it should be good to go. All right, now it'll compile. And something really interesting is going to happen. So it's going to run down here. When I click this button, it's going to run just normal main thread until it hits this await. And then it's going to say, all right, well, this is not done. I've got this task back. I'm waiting for the task to complete, but it's not done. So it's going to release the main UI thread to keep working. And it's going to convert this second half into a continue with. And when the task is finished, it's going to put a message on the message pump. It'll pull out and it'll continue processing this bit. And it gets a little more complicated because we're in a loop, so you can kind of think maybe, well, it'll just run down within the loop, then it'll turn it into another continue with and another continue with and so on. And we'll look at this in disassembly in a minute, but let's just run it and see it working. Okay, so we searched for iPad before. Run, see it's moving, results are coming in, we've hit CNN, now we hit CNET, and now we got breaking news from that place, which is what, MSNBC or something? Okay, look at that. We've done almost no work. We've just put async and await, two different locations, and down here in the downloader, we've used converter from the download string to download string task async. And so what the C# compiler does is it basically writes the code that we wrote in the first example we saw in the console application. It says, okay, well, we need to break this into a bunch of tasks, and the stuff that happens after the task is done is a continue with, but it adds on some additional magic to actually keep this happening on the right thread. Okay, so what's really interesting here is when I go and search for, like, I'll search for truck or something. Okay, so when I go do this search, I'm still able to update the UI from the background, from these sort of asynchronous pieces of my application. I don't have to, check and see, is it a background thread, and cycle it back over to the main thread. And So that saves us tons and tons of work. We could actually go and ask it. We could say something like, let's say, debug.writeLine, current thread ID. We could say thread, sometimes IntelliSense gets too helpful, dot current thread dot manage thread ID. Okay. Let's say that here. I can say that here. And let's also say it right in the constructor where we know it's on the UI thread, okay? Which is right, let's say right here. Okay, so if I run this in debugger, it should always have the same ID. There's no extra threads. In other words, the kind of work we're doing is this bottom version of asynchronous programming, not the top version. There's ways to do the top version with async and await, but what we've done so far is not it. Okay? Oh. And you cannot update it while it's running. That makes perfect sense. Okay. So go and run it. And whoops, let me run it in the debugger so you see the debug output. And let's search for iPad again. And down here in the output window, you could see right in the beginning, current thread is 9. Did I ever press go? I guess not. There we go. Now it's going. So see all the stuff before we download the content, after we download content, it's all the same thread. We're not doing multi-threaded programming, we're doing asynchronous programming, which is a broader concept, right? Okay, so let me undo those guys. We don't want that messing up our code here. And excellent. Okay, so let me show you one more thing I'd like to do. What I would like to do is I would like to look at this method, update stats. So what I want to do is every so often, I would like to go and ask the search system, which is doing the download, how many downloads you have pending, what thing are you currently processing. So if you go and look at here, it says idle at the bottom. And you may have noticed it always says idle. Even while it's downloading, it says idle. And so there's this update stats piece that's supposed to update that. Okay, so let me just go and call it at the beginning, right in the constructor, right when we create our application, we'll get started and do this, okay? But notice, while true, when do you think that's going to return? Never, right? It's an infinite loop. So if I go F5 and I run this, well, it's starting our app, and our app is running. You can see Web Searcher down here is actually running, but it's not showing the window. And the reason it's not showing the window is it's never even returned from the constructor. If we hit pause, then go up the call stack one bit, right here you can see it's still stuck in update stats. Okay, so that's not surprising. You know, you've all known that if you write a while true loop and you never break out of it, well, you're kind of stuck there. But let's do something really interesting here. Let's say we don't want to do this too often. So we can say this. We can say task.delay. We can say we want a task that will complete in 200 milliseconds. Now that seems completely useless, but we can put a wait in front of it. And of course, this means we have an async here. If we put a wait in front of it, what it does is it's going to say, okay, program, run to here, and then release program control for 200 milliseconds, and then run this little bit of code, and then release program control for 200 milliseconds, and so on. Now, in the constructor, I didn't update how I'm calling this. I'm not doing anything different. I just call update stats. But you're going to see something pretty amazing here. First of all, we're still calling it, and our UI is now working. If I say iPad and I search, watch the bottom, the status bar. 23 pending, we're searching Fox News, MSNBC. So we've essentially kicked off like a background task that every 200 milliseconds is checking the status of the search engine and updating it. And yet, it's doing it on the UI thread. it's created this mechanism by which every 200 milliseconds the Windows message pump goes and continues working, right? So that's really, really interesting. And if you look at the CPU usage, it's still super, super low. This is, that adds almost no overhead because the amount of time that takes to run versus 200 milliseconds is like 0.000. It's super, super small. Okay, so that's a really interesting use. We have maybe 14 minutes left. Let me look at the slides for a minute and sort of catch us up there, and then I'll show you one more way to sort of go down this more towards true parallelism. We won't actually go and do too much of this, but one thing that you notice is if I go and run this over here, in the output window, it shows us what it's searching. Let's just do a clear. Okay, and so if I go search for iPad up here, or if I could spell it right, you'd see it's first doing CNN, then Fox News, then MSNBC, then NPR, then Boston News, then Dallas News. It's doing them in order, right? There's no actual parallelism. Like we saw with our Expedia example, that really had parallelism. Stuff happened faster. This is no faster than before. It just lets my UI update and my screen get moved around. And if I wiggle it, apparently I'll minimize Visual Studio. There we go. Okay, so the last thing in this example to do is to actually make it do stuff in parallel. Okay? So it turns out that that's not hard at all. We just have to rewrite one of our methods here. So the thing is, this method is asynchronous, but what it does is it runs down and it waits for one thing to finish, and then it processes it, and then it starts another one and waits for it to finish, and then processes it, starts another one, waits for it to finish and process it. Okay, what we need to do is start them all, and then when any of them are done, then we want to actually go and process them. All right, so what we have to do is write 2 for loops. Okay, and this turns out to be a while loop at the bottom. Let me just say false for a minute. Okay, actually true, just so it doesn't get grayed out by ReSharper. Okay. Now there's a few things we got to patch up here, but let's do this. Let's create a list of tasks. Oops, got to import. This IntelliSense is too much. List of task. Downloads equals new list. So what we're going to do is instead of waiting on these right away, we're going to do this. We're going to say downloads dot add. Now first we'd start out writing something like this, right? Just gather up all the tasks, and then later on we're going to wait on them. But it turns out we have this problem because we actually need 2 pieces of information to process the result. We need what the URL is and what the content at the URL is so we can search it. Right? We need to know the URL, so if you double click it, we can take you there, and we need to know the content so we can search it. So what we have to do is we have to basically create a simple object that just stores both the URL and its content. So at the bottom, I've got this little super simple method here. This thing we called download result. Okay, and all it does is it just calls downloader.download HTML, but it also creates this download result and stashes it together. Okay, so we're just going to call this. We're going to create a list of these things. It's going to look kind of ugly in the delegate style here, or in the generics, but that's okay. So what we need is a list of task of download result, right? This is a good time when maybe one might want to say var and forget how ugly it looks. And then instead of doing this, we're going to just say download URL. Okay. Now we're not really doing anything complicated there. We're just creating an object which holds both the URL and the HTML. So the next thing to do here is we're going to create a task of download result. result. What we're going to do is we're going to go to all of our downloads and we're going to ask it a question. We can say task.when any. Okay, when any of these tasks are done, we're going to store them in here. And maybe result is already used, so let's call it finished task. Okay. So when any of these are done, we're going to grab that download result. And we also need to go to downloads and say remove finished task. All right. And this returns a task of a task, which is kind of crazy. So we need to just do an await. So we're going to await. Whenever the first one's done, we're going to get the result back, which is one of these tasks. Okay. And let's actually put this down here. And the question we're going to ask for our loop is we're going to say while this count is greater than 0. Then we'll say finish task.result.url. And down here at the bottom, we're going to say, instead of HTML, we're going to say .data. Data is the HTML. Okay. So instead of awaiting each of them, we're going to start all of them. And then as they finish, that's what when any does. We could say when all, and that would just block till they're all done. But we want to process them as they get done. So we're going to say when any of them are done, give me the first one that is done. We'll take it out of our pending list, process it, search it, and then wait again for more to come. Okay? So if we run this now, you should see this go much faster. All right, so first let me clear out this window. At minimum, you should see them go in parallel here. Okay, so let's go search for iPad again. Run. See them all downloaded in parallel, and they're all finished. Okay, so search again. I can move around. Now they're all finished. Okay, pretty cool. I see there's a question. If two finish at the same time, would that logic skip the second one? Great question. No, it wouldn't. It wouldn't skip it. Basically, this thing, if two of them are done, it would just go through the list and return the first one that's done, and then it would immediately, basically the second time through that loop, it wouldn't wait. It would immediately return the second one rather than the first one, because that second time there's only one that is finished. Okay. So yeah, no, that would be fine. Now, you might have noticed, it's probably really difficult over GoToMeeting, but if I search, and as I move around, it's sort of stuck, right? It's not quite as smooth of an experience. And the reason is, this second part now is starting to dominate the processing, because we're downloading so much so fast. The search engine actually takes a little bit of time to go through all the HTML. There's a fair amount of string processing to get through all those home pages, okay? And so this part, which is not asynchronous, is starting to really bog down the system. So what we could do is write a method that does this stuff in serial, write one that does it in serial, and then use convert them to tasks. Okay, so the way we would create something like that actually runs on a background thread is you would say task.run. All right, task.run is kind of like the task that we had before, but it actually creates one. Here you can see right in the description, queues specific work to run on the thread pool and returns a task for that. Okay, so that lets us get back and do some of this true computational processing. All right, I don't think we have enough time to really go into that. It's kind of a little bit tricky. It's not super hard or anything, but let me just make a note then. Convert these calls to task.run. Then you get, maybe we would want to say await task.run. Then you get full parallelism. Okay. All right, so I think that does it for our demo. We started out with just a purely straight single-threaded application. You saw that we made the UI responsive simply by adding await and converting async and await in two simple locations, and then converting from download string to download string task async over in our downloader piece here. Right? Just add task async and then await and async. but that didn't actually add more parallelism to it because we were awaiting each result, still sort of doing them in order. So we had to actually change our logic ever so slightly to these two loops, first start all the operations and then pull them out as they're done with task when any to actually get more parallelism out of the system. Okay, so hopefully you guys got a good idea of the C# stuff that's happening. The last thing I want to do, let me go over here and go to the folder here. I want to disassemble this thing and see how it looks. So if we go over here, when we had this as just the simple version, let me throw in something I'll just call serial and just make it a string, just so we can see it in the disassembly, so we know kind of what we started with. Wait. There. Okay, so let's look at this in Reflector, which I thought I had open, but I guess not. So hold on a second. Down here. Here we go. Yes, and let me go ahead and close it so it'll actually build. Okay, so let's go and throw this into Reflector here. That it would be the web searcher.exe. I think here. Let's close that up. Okay. Oh, it's .NET 4. Oh, it does not support .NET 4.5. Interesting. Well, maybe I won't be able to show it to you, but I can still at least tell you what's in there. So if you look at what's happening inside here, if we disassemble this version, right, this download HTML serial, it would look very, very similar to what you would expect. But if you throw this version into Reflector, which I do have two versions. Let me see. Maybe it's the second one down here. Nope, same problem. Okay, well, what you would see is basically it creates a state machine. Okay, and it looks absolutely nothing like what you see written here. There's a whole bunch of classes that are created, and this code has a bunch of go-tos, believe it or not, in it. It looks really quite unusual. But basically, if you were to work out what it's doing, it says run this code down to here till you see the first await on the main thread, the calling thread. Convert this to a task. This download task a string, really it is a task already, so there's not much to do to it. But then convert this last bit here to actually a task.continue with. Okay? So that's why it's super important that you guys get that task stuff down, the continue with stuff down, because really that's what the compiler is doing for you. All right? But the real benefit is we don't have to write inside-out code that, sort of creates a bunch of delegates and passes them off and then waits for them to finish. That turns out to be really hard to do. Right? You just write regular serial code and then you let the compiler turn it inside out so that it can be asynchronous. Okay? So questions, comments? I think I'll just leave it at that.